In this video, I introduce the Inception modules in GoogleNet. Inception modules in GoogleNet improve performance of deep convolutional neural networks, which is inspired by having in principle neurons that fire together, wire together. Compared with the previous convolutional neural networks, GoogleNet uses inception blocks consisting of 1 by 1, 3 by 3, 5 by 5 convolution filters, and 3 by 3 max poly to increase computational efficiency by using multi-level filters in one layer. This naive inception module. This is input layer, this is output layer. We use 3 convolution filters and 1 max poly. That is showing in 3D here. For example, images with different dark size inside require different resolution to detect the darks. Inception uses different filters together to scan the images to increase the network performance. If input layer and output layer include a large number of feature maps, convolution operations may be time-consuming. A dimension reduction technique using 1 by 1 convolution is applied inside Inception modules to reduce number of input maps. For example, a 1 by 1 convolution maps an input layer of n channels into output layer of l channels, and 5 by 5 convolution kernel uses l channels as an input rather than n channels. For example, in the naive reception module, we directly use a 5 by 5 filter to map an input layer with n channels to an output layer with m channels. Now we insert a 1 by 1 filter that is used to map an input layer with n channels to an output layer with l channels, l smaller than n. And then now we use a 5 by 5 filter to map the l channels to output layer with m channels. GoogleNet uses 2 auxiliary classifiers to reduce gradient vanishing, which enhance the gradient flow in the lower stage of the deep convolutional neural networks. The auxiliary classifiers are only used during training, while only final classifier is used at test time. During training, the loss calculated from auxiliary classifiers is weighted, for example, 0.3, and added to the total loss of the network. One classifier is here, and second is here. This is the final classifier. Details of average polling 5 by 5 plus 3V is showing here. GoogleNet consists of inception modules, convolution layers, max poly layers, and local response normalization. Local response normalization is used during training and removed at inference time. Non-inception modules are used to reduce number of model parameters. Softmax function is used as output layer to predict the probability distribution over the object classes. GoogleNet has 22 layers, 27 including 5 polling layers with a total 5 million parameters. This is the architecture of GoogleNet. This is input and this output Here shows the number of convolution kernels in each Inception module. Here, the two auxiliary classifiers. For more details, please check with these references. Thank you. Bye.